Okay, RL parallel circuit. So, if we have two components, a resistor and an inductor, a resistor R and inductor L, connected to an AC supply in parallel, then we've got a common voltage to both components, Vs, so that becomes a reference phasor, and then we get two separate currents. We get an IL through the inductor and an IR through the resistor, and those two would sum together to make the overall current I. We draw a phasor diagram for that. The blue phasor is Vs. The red phasor is the resistor current IR in phase with the supply voltage. Always, you know that resistors have voltages and currents that are in phase with each other. However, the inductor current is 90 degrees lagging behind the resistor current. And then we can sum those two currents using Pythagoras theorem. So the current I down the hypotenuse of the triangles there is IR squared plus LL squared square root of naught. And we can find the angle using the inverse tangent. So we've done some work with that with series circuits before the holiday, where we were finding the two voltage components. Here we can find two current components. One thing you have to be careful of here is that the total impedance for that circuit is not the vector sum of the two separate impedances, because they're in parallel. Remember, to do parallel, we would need to use, so to get the key here, we'd have to do ZR times ZL over ZR plus ZL. We'd have to use product over sum. It's not a straight, because they're not in series, it's not a straight addition. Okay? And the maths to do that is beyond the level that you need, that we're doing this module. We'll probably be doing that anyway. Okay? So you can't find the vector sum, you can't do the vector sum of the two impedances to get the total impedance in this case. Right. We could, if we got Vs and we calculate I, we can get the total impedance from Vs over I. We can do that. Everyone happy with that? That's it. Yep. I'll move on. So, example. 20 ohm resistor. Connected in parallel with an inductance of 2.387 millihenries. That's across a AC supply that is 60 volts at 1 kilohertz. Excuse me. Bless me. So that's the circuit we're looking at. Calculate A, the current in each branch. So we've got an IR in that branch. Calculate. We've got an IL in that branch to calculate the supply current. IS and circuit phase angle, circuit impedance. Well, we're going to start with that problem. So, how can we calculate IR? law. So it's equal to Ohm's law is V equals I times R. So I is equal to, in this case, a Vs over R, which is 60 volts divided by the resistance equals 3 amps. Yeah. For completeness, the angle here is 0 degrees because that's a resistor. Yeah. So that's nice and easy. Now, how do we calculate the current IL? Well, if we use an Ohm's law again, it's all we got about first, so we must have Vs. But what's the equivalent term of R for a resistor when we talk about an inductor? Still measured in ohms. Remember, XL, inductive reactance. Remember that from before Christmas? How do we calculate that? How do we calculate XL? Have a look through your notes, see if you can find them. Yeah, you're getting there. 2 pi times the frequency times L. Yeah, L, the inductance in henries. Okay, so what we can do now is say, therefore, IL is equal to Vs over 2 pi FL, and do all that calculation in one go, so there's no in between rounding. Put the numbers in. 60 volts divided by 2 pi times 1000 times 2.387 times 10 to the minus 3. And what do we get? Yeah, 4 amps. Yeah. Okay, so if we were to draw a phasor diagram of the currents, we've got IR 3 amps, IL 4 amps. And we can now find I. Yeah, I. B I is equal to root IR squared plus IL squared. Root 3 squared plus 4 squared. Five amps, 345 triangle. Test it with your calculator. That's B, that is. A is find the two currents. Currents in each. That's part B. That's right. Everybody up with us at this stage? Yeah. Good. Right. Circuit phase angle. So that's this one in here. That is tan to the -1 of yep. Which is well, degrees is fine. Lagging or leading? Remember, we consider, yeah, well, you can use civil, but remember that phasors move round in an anti-clockwise direction. Yeah, so the voltage is about, remember, it's the relationship between this current, I, and the voltage, which is at 0 degrees. When we're talking about anti-clockwise direction of movement, the voltage is ahead of the current, or the current is lagging. Yeah, is that correct for an inductive circuit? Inductive circuit, voltage comes before current. Right? Yeah. So we got 51. We got a current of a supply current of 5 amps at angle 53.13 degrees lagging. And in full terminology, what you'd do is say that current is 5 amps, angle 53.13 at a negative angle to give the lagging part of it. Alright? And you'll learn some more mathematical degree symbols is important as well, because otherwise radians is assumed. You'll learn some other mathematical techniques that will allow you to calculate those values different ways as well, electrical principles. Alright. Last bit D, circuit impedance. How do I calculate circuit impedance? Yeah, 60 over 5 equals 12 ohms. Yep. And the angle will be the same as that angle. No, it's not asked for. Okay. All happy with that? Yeah? Good. Right. So, one last little bit for me to go through before I give you over to your assignment work. Bearing in mind there's some other problems in these notes if you think you need more practice. Okay. it's possible solving problems graphically or estimating is possible and is a reliable estimating technique to determine the results for AC circuits using graphical methods. Alright, this involves the use of a rule, a protractor, to draw the phasor diagram carefully to a suitable scale. The unknown values can then be determined by measuring with a ruler to find the lengths of the lines and reversing the scale, and the protractor to measure the angle. So for example, 5 ohms connected in series with a resistor of 6 ohms. Use a graphical method to determine impedance Z and its angle theta. First of all, before I demonstrate, because I doubt whether too many of you have got a protractor and a ruler. You might have rulers, but I doubt whether you've got a protractor. I'll demonstrate this, but first of all, please calculate the impedance and the angle of that impedance for a 5 ohm resistor and a 6 ohm, 5 ohm inductor and a 6 ohm resistor in series.